Okay, so we're switching over here to volume of pyramids and cones. So you've got the two formulas written right here. On PowerSchool Learning, there is a video underneath this that goes with this that kind of shows why. But there's a picture over here to the side, and what we would do if we were together is I would have little props here, and we would take this smaller pyramid and see how many times it would take to fill that up, and then dump it into the larger prism and see how many pyramids it would take to fill up a prism. Well, it turns out that it takes 3 of them, which is where the 1/3 comes from. And we would do that if we were together, but I don't have all my little props here. So I did add a video to PowerSchool Learning so you can kind of see that visualization of 3 of these pyramids adding up to a prism of equal base area. So if you want to know where the 1/3 comes from, that video is on PowerSchool Learning. Okay, so we have our 2 formulas here. For the cone, we're going to use 1/3 pi r square h, and then any other pyramid, we're going to do 1/3 base times height. Again, remembering that all of our bases are going to be regular shapes, so there won't be any rectangular pyramids. They'll all be square pyramids, or regular hexagons, pentagons, or circles. Okay, now you won't see any rectangles, but we can still see triangles. So you're going to see a triangle here. We'll do this one. We'll do a cone, and then we're going to go to the actual practice problems as well and do some of those together. Okay, so volume equals 1/3 the area of the base times the height. Okay, now this is really difficult to do when we're not together, but this height right here is going to go through the middle of the shape, and that's shown here in the picture of the square pyramid as well. That's going to go right into the center of the base, okay, from the vertex there, and it's going to go right in straight through the pyramid to the base. So this 9 is our height. Okay, so volume equals 1/3. I'm going to put the area of the base in there, and I'll multiply that times 9. Now the area of the base, this is our 4 by 6 triangle, and on Monday we actually found the side of this triangle, but we don't need to do that today because we just need to find the area of the base. So to find the area of this triangle, we take 1/2 times 4 times 6. Okay, so now let's simplify this up a little bit. So I'm going to leave the 1/3 there for a second. 1/2 of 4 times 6 is 12, and then we'll take that times 9. Now, if you're wondering about how to do this in your calculator, what I would do is I would take 12 times 9 and then just divide it by 3 to get the 1/3. But you can also just do, in your calculator, 1 divided by 3, that's 1/3, times 12 times 9. 36. So 36 meters cubed. Okay, and that is the volume of this triangular pyramid. Okay, I'm going to turn the page. This is an oblique, and we talked about that on Monday, that we actually won't have any oblique prisms or pyramids or cones or cylinders on the quizzes that we have. So I'm going to go ahead and turn the page here. We'll do a right cone. Again, we won't have any going backwards problems, although they're interesting if you want to see them. Okay, so here's what we've got. This is where we're going to spend a lot more of our time, especially when we go on to the problems that are from the practice, is the volume is 1/3 the area of the base times the height, which when you looked on the formulas that we saw at the beginning, since the base is a circle, it changes that base area to pi r squared each. And you don't have to remember that. This formula right here is written on your formula sheet. Okay, but that's where it comes from. Okay, so now the issue of the day is height is that number, which we don't have. We have slant height. This slant height of 8 does make a right triangle with a radius of 5, but it is not the height. We actually have to go and find that height. So over to the side, we're going to do a Pythagorean theorem. This is going to be a little bit more of the backwards type Pythagorean theorem. So I'll put a little h here. So it's 5 squared plus h squared equals 8 squared. Okay, now this is a subtraction. This is what, remember, we call this a subtraction Pythagorean theorem. So in your calculator, if you just want to do 8 squared minus 5 squared, that's fine. Or we can work this out even more. So 25 plus h squared equals 64. And now we'll subtract 64 minus 25. So h squared is 39, and then I can square root that to get 6.24. So that number, 6.24, is going to go in for my h, and my radius is going to be 5. All right, so here we go. 1/3 pi 5 squared times 6.24. Okay, again, because it's going to ask you to do it to the nearest hundredth, which is 2 decimal places, you can just type all of this in to your calculator. If you're working with this calculator, you could just hit times and it would pull down that answer. But I'm going to guess a lot of you are probably working with that Desmos on your calculator or on your phone. So 1 divided by 3 for the 1/3 times pi times 5 squared times, and then right here again, if you're using this calculator, you can go second answer and just pull down that answer, or you can type in 6.24. Okay, so I've got 163.36, and that would be meters cubed. Okay, so I'm going to slide back here into the practice problems. So I've got surface area 11.6, which was from Monday, and this is 11.7. Okay, a couple pieces of information here. We are going to do the first 6 problems here, 1 through 6. Those are problems that are good practice for the quiz. Down here, you're going to see some degree measures, 60 degrees and 32 degrees. Those problems are not going to show up on the volume quiz, and neither are the combined shapes here on the back. So 14, 15, 16, and 17, those will not be on the quiz either. They're very interesting, and I can upload a video on how to do those, but I want to keep it focused for the quiz. Okay, so what we're going to do is we're going to go through and just label the height, okay, and the slant height, just so you can see, because again, this coming Friday is a surface area quiz where you would need slant height. Okay, so here we've got radius, we've got height, and then this would be slant height. Now, you don't need slant height for volume, you need it for surface area. So this Friday, you would need to do a Pythagorean theorem to find this, but you wouldn't today. Okay, and then the second one here, same thing. You've got your height, that's what you need for volume. We would slide this over, and here would be your right triangle. Okay, you don't need to do that for this one again because this is volume, and for volume you need height. But the only reason I'm showing you this is because on Friday is your surface area quiz, and for surface area you do need slant height. So again, you'd have to do a Pythagorean theorem if you were looking for slant height. This one here, this is the one, number 3. You're given the slant height. You actually need to find height for volume. Okay, so that just kind of shows you that triangle again between radius, or this would be 2.5 because it would be half of this 5. And again, radius, height, and slant height. Height and slant height. Okay, there will be no oblique shapes on the quizzes either this Friday or next Friday. And because there's already 2 cones, you don't have to worry about that one. This one here already gives you the height. And so does number 6. That already gives you the height. Okay, give those a try. The answers are on the back, remember, the last page. And if you have questions, we'll go over those in class.